Okay, in this video, I'm going to be discussing the hybridization in Ethyne, and there is a quick shortcut to figure out the hybridization on each carbon, and that is by adding the number of atoms it's connected to and the number of lone pairs. Well, we can see this carbon does not have any lone pairs. It has a hydrogen atom and a carbon atom connected to it, so that's sp hybridization. Just like this carbon has a carbon connected to it and another hydrogen connected to it, so that's also sp hybridization. Now that's the shortcut, and it really doesn't give us an idea of why we're doing this. And I'm going to explain the whole why we're doing this. So a good thing to know is a triple bond. So a triple bond has two pi bonds and a sigma bond. So what is a pi bond? Well, a pi bond occurs when two p orbitals, so these two things right here is p orbitals. So when two p orbitals overlap twice, so we have an overlap here and an overlap here, that's a pi bond. If they arranged like this, we can see we have a sigma bond because they only overlap once. So a pi bond is where they overlap twice, a sigma bond is where they overlap once. This orbital over here is our sp hybridized orbital. It has 50% p character and 50% s character. And this right here is just an s orbital, just a circle. Okay, so over here we have our electron configuration of carbon. And you can see here in our energy diagram, we do not have our 1s2. And the reason why we do not have our 1s2 is because those electrons are extremely close to the nucleus. They are not valence electrons. They are not going to exhibit any bonding. So we can totally omit them for clarity. So let's fill in our diagram here. So we have two electrons in our s orbital, and we have two electrons in our p orbitals. So we need to have two pi bonds and a sigma bond. And pi bonds occur when there's p overlap. So immediately we should know that we're going to need two electrons in two p orbitals so we can create pi bonds. But what we're really doing here is we're going to bump one of these electrons, doesn't really matter of the two. We're going to bump them up because we can do that because it's very low energy gap between these. And we are going to hybridize 2s with one of the two p's. So when we do that, we will be creating an sp. So we're hybridizing one of these, the s orbital, really, just the s orbital and one of the p's. We're leaving two of the two p's alone. All right, so let me fill in our diagram down here. This is what it's going to look like. We'll have 1, 1, 1, 1. And we can count our orbitals. See, we didn't mess up. We have 1, 2, 3, 4 orbitals. 1, 2, 3, 4 orbitals. So everything's good. Moving on. Let me move this molecule out of the way so we can see our structure. Okay, let's start with this carbon first. We have two sp hybridized orbitals on that carbon. So let me duplicate this again. So we have two of these orbitals. Do that right here. And we'll do that right here. And we also have these two p orbitals that have one lone electron in each of them. So here's one of those p orbitals. And here's our other p orbital. As you can see, it gets quite messy quickly. Let's just do that. Let me move this a little bit over. All right, that's fine. Anyways, that's our carbon atom hybridized. And our carbon atom, you can just think of the C is, our C is right there. That's where the carbon atom, the nucleus, is residing. And now we can look at this hydrogen over here. And hydrogen's electron configuration is 1s1. So it has an s orbital. So what does the s orbital look like? Well, it's just a circle. And that one electron in this orbital is going to bond with this one electron in this sp orbital. So if you want to think of it this way, this bond right here is a S to a sp bond. That's what that is right there. Let's reconstruct this carbon over here because it's going to be the same thing, because this carbon atom goes through the same hybridization as this carbon, because it has a triple bond here, and we know a triple bond contains 2 pi bonds and a sigma, and it's also connected by only a hydrogen. So I'm going to duplicate that. Let me just move this up here. We have 2 sp orbitals. We also have 2 pi orbitals, 2 p orbitals. And let's arrange it. So, like this, we have a bond there, our other sp orbital, and our pi orbitals. Okay, and we also have this hydrogen here, so we're going to need another 1s orbital. And so we have another s. Oh, that didn't duplicate. Let me try that again. There we go. So we have another s to an sp bond right there. Now we have our sigma bond right here in the middle between these 2 carbon atoms. So let me just do this. Carbon atom here and a carbon atom here. That's our, well, that's if you want to see where our C is. And our H is like right here. Yep, that's all of our atoms. Anyways, that's our single bond, and that's our other single bond right there. But I'm going to remove that so we can actually see what we're doing here. So right here in the middle is one of our bonds, one of our 3 bonds, and that's a sigma bond. So this middle bond right here is a sp bond and is a sigma bond, and that is denoted by this symbol. It's like a little O with a line. So it's a sigma bond. And these 2 p orbitals, remember, have 1 lone electron in each of them. So they are going to form a pi bond. So there's a pi bond. And also these p orbitals are going to bond with this p orbital all the way over here. And that's our other pi bond. So we have 1 pi bond with these p orbitals, and we have another pi bond with these p orbitals in the back here. So that's our 2 pi bonds, and that's our 1 sigma in the middle. And that accounts for our triple bond. Now that is why carbon will undergo sp hybridization when we have 2 bonds or 2 atoms connected to it. Remember, triple bond contains 2 pi bonds and a sigma, 1 sigma, and a double bond contains 1 pi bond and 1 sigma, and our a single bond is just a sigma bond. So if you want to write that down, that's what that means, and that is why in ethyne each carbon undergoes sp hybridization. I hope this video helped. If you have any questions, just comment down below and I'll help clarify.